The given problem is climbing stairs. You are climbing a staircase. It takes n steps to reach the top. Each time you can either climb one or two steps. In how many distinct ways can you climb to the top? So as per given the example, if n is equal to 2 steps, there can be two ways to climb to the top. That is one step plus one step or two steps. Or if n is 3, there are three ways to climb to the top. One step plus one step plus one step, or one step plus two steps, or two steps plus one step. Let's visualize this here. If there is one step, there is one way you can go. If there is two steps, you can go two ways, that is one step and one step, or directly two steps. If there is three ways, you can go one step, one step, one step, three ways, or two steps at a time, and one step, or one step plus two steps. Let's understand in a brute force kind of, like let's suppose if there is n is equal to 1, you can simply return 1. If n is equal to 2, you will simply return 2. But what if there is three steps? Let's suppose uh, to reach third step, if suppose imagine you are on the second step already. If you are on the already in the second step, so you should understand here one thing before is, how many ways we can go only through, like it can be like one step or two steps, right? So to reach three, you can start from second step, or that is a one way, plus you can start from before two, that is first step. So you can take two steps from the first step, or from the second step you can directly take one step. So there's two ways. So it is like to reach third. So to reach the third, there are three ways. So second step, itself takes two ways, right? Then first step we take one way, so it is 2 plus 1. So it's look like a Fibonacci series here, like fib of n, that is equal to fib of uh, n minus 1 plus fib of n minus 2. So the similar kind example you can take here. Suppose let's you are on the fourth step. You can start from, if you can take one step directly from third step, or you can take directly two steps from the second step. So it is like number of ways to reach four. It is like four step is like number of ways to reach third step plus number of ways to reach second step. So it is kind of brute force, and it is kind of you can think this like backtracking, or it takes more time complexity actually. So if n is equal to 1, we are simply returning 1. If n is equal to 2, because these are the base conditions, we are following the recursion here. These are the base condition, and the main condition is we are directly returning climb states of n minus 1 plus that is a observation we made just previously, climb states of n minus 2. So first let's try to run this code, and the time complexity is kind of t of n minus 1 plus t of n minus 2. So when you run, the time complexity is very big, right? So it can't take, suppose n equals to 4, it should go like, suppose n equals to 4, first it should start, it should find 3, then it should find 2 again, for 3 it should find 2 and 1 and 2. It is a base condition, fine. If you take the number like 45, so basically I want to show like it will be like this. So so here we have the concept called dynamic programming. So when you are solving the kind of recursion problem, that too it is like the main problem is divided into sub problems, and sub problems can be overlapping here. Suppose if you take the base condition, here the base condition is n equals to 1, that time it is n equals to 1 time it is 1, n equals to 2 time it is 2. These are like two ways, right? But when equals to n equals to 3, we are taking n minus 1 plus n minus 2. So they can be overlapping sub problems. So we need not calculate again the sub problem overlapping. We can use memorization further in the dynamic programming. And so for that we have like two methods. One is bottom up approach. In the bottom up approach, what we can do is we can just start from like directly we'll first find out fib of 0, like we need fib of 1, right? Usually, so it fib of 1 it usually take one step. So fib of 2 it will be like, so I will just start writing the code first. Here it will take some extra memory, like int of a is equal to new int of n plus 1. So first time it's hard to visualize these things. So then I will start if n is less than or equal to 0, I will simply return n, and it is like a kind of base condition. Then if n is equal to 1, I'm just simply returning the 1. Then now now it is not if, I'm using else if, then else condition I will write now. Now I'm putting a of 0 is equal to 1, because a of 1 it takes 1, right? So if you write here for loop for int I is equal to, I'm start from 2 and I is less than or equal to n, and I plus plus. Now a of I is a of I is equal to a of I minus 1 plus a of I minus 2. So a of 0 it is so if you keep counting it will go like a of 0 it is 1, we taking for that reason. So a of 2 now become 2, right? Now a of 3 it will become, so 2 plus 1 3. So it will go further, like it follows a Fibonacci series. So at last we will return that a of n. So it is bottom up approach. We are not using any recursion of anything, so we are submitting, it can submit it. And we can solve it one more way, that is top down approach. Now it's like I will directly I don't start from base to up, I will start from up to down. Like I will start from directly like I will take that fib of again I will take directly. And for that it's just like, when suppose if you see here fib of 5, suppose when you encounter fib of 2, if it is already calculated, if it's already visited, no need to visit again. So for that I will just take one array of size n plus 1. Then I will make inside everything like I will fill everything with minus 1, and just check if my fib of that particular n value, if is equal to minus 1, that is if it is not visited, then I will go to inside it. Again inside it, it's like if n if less than or equal to 0 will return that n, and this base condition said if n is equal to 2, we return 2, that is. But for that the main condition is like, we'll just write inside the array itself, like that array of that n is equal to, we will array of n we will write like now fib of our n minus 1 plus fib of our, we just returning, we are just storing that result in the array. So whenever if it is visited, if it is not visited, this condition, if it is visited, we will directly take that return of uh, fib array of that n. So this is what we call memorization. So this is the concept of dynamic programming to solve this problem.